Hello again. As you know, I am Eli, the computer guy, and today's class is Introduction to DHCP. DHCP stands for Dynamic Host Configuration Protocol. This is the protocol that is used to dynamically assign IP addresses to client computers. So if you've done anything with TCP/IP, you know that all computers, all devices on a TCP/IP network require an IP address. Now, way back in the horrible, really old days, you used to have to statically assign IP addresses to each and every device or computer on the network. You actually had to open up their little network configuration control panel and add the IP address manually there. That was a big pain in the butt. That was a big nightmare. So thankfully they came out with what is called DHCP. DHCP dynamically assigns IP addresses to client computers and network devices. So if you plug your computer into the network, or if you plug a network printer onto the network, or if you connect to a wireless network and you are automatically given an IP address, that is done through DHCP. So that is what we are going to be talking about today. Now, the first thing to realize with DHCP is that this is a server service. So this is a service that will be performed by a server. Whether this is a Windows 2012 server that's been configured to do this, whether it's a Windows 2000 server, whether it's a Linux server, whether it's a Unix server, or whether it is your router or your ISP's modem that is in your house, these are services that will be provided by a server. The other thing to realize about DHCP is that all that it does is dynamically assigns IP addresses. Now, one of the big problems with new technicians is they think that certain services do more than they actually do. So normally, when you're thinking about dynamically assigning IP addresses, you're also thinking about DNS, so resolving domain names to IP addresses. Well, DNS, domain name services, is a separate service. So a lot of times DHCP and DNS can talk to each other, but they are entirely different services. They can be installed on entirely different servers, and so they are separate things. All DHCP does is it dynamically assigns IP addresses. It has nothing to do with domain names. So this is a very important thing to understand. So when we're thinking about DHCP, Dynamic Host Configuration Protocol, we need to be thinking about what DHCP does. So you connect your computer to the network, and the DHCP server will provide it with certain pieces of TCP/IP information. So the first thing that it will provide is what is the IP address of the computer. So it will automatically assign the IP address. It will then also give it whatever the subnet mask it should be is. So the IP address may be 192.168.1.1 with a subnet mask of 255.255.255.0. Then it will also give the default gateway. So the default gateway is the router or modem that allows the computer to basically talk outside of the local area network. So to connect to the internet, connect to the WAN, the default gateway is the router that gets the computer off of the local network. Then you have the primary DNS server and the secondary DNS server. So these DNS servers, again, as I talked about before, these are separate servers, and that's for the domain name resolution. Basically to say that the computer named server actually has an IP address of 192.168.1.1. So that's what the DNS does. So when your computer grabs the information from the DHCP server, it's going to get its IP address, it's going to get its subnet mask, it's going to get the default gateway for the network, it is going to get the primary DNS server, and it's going to get the secondary DNS server. Now, what is going to be given dynamically is that IP address. So whether it's 192.168.100 or 192.168.1.125, that will be given dynamically. The other items that I just talked about, though, will be static configurations. So the subnet mask will be static. The default gateway will be static. What this means is you plug it in once and it will give that information out to all of the client computers. This is a big big problem for a lot of new technicians because they fat finger something, and then all of a sudden all the computers on the network that are grabbing these dynamic IP addresses will no longer communicate on the network properly. The reason generally is because when the administrator plugged in what the default gateway should be on the DHCP server, he hit the wrong number, and therefore all the computers are trying to access the wrong default gateway. Or for the DNS servers, again, a lot of times the administrator will plug in the wrong number for the DNS server, and then all of a sudden, none of the clients on the network are able to resolve DNS names because they're pointed to the wrong DNS server. So one of the things to realize is that the dynamic part is that IP address. The other things are static. So for the rest of this, let me go to my new little digital whiteboard so we can explain a few things here. So as I talked about, well, I just said that the IP address is given dynamically, everything else is static. Well, the IP addresses that are given dynamically are given from something called a scope. So the scope is the range of IP addresses that the DHCP server is allowed to give out. So many times you'll be looking at a scope and you'll have a scope of, let's say, 192.168.1.100 to 192.168.1.200. What this means is that the scope of this DHCP server is 192.168.100 to 192.168 to 200. So that means that this DHCP server could give out an IP address of 101, 110, 151, 199, even 200. So it can give any IP address between 192.168.1.100 and 192.168.1.200. It would not be able to give out an IP address such as 192.168.1.201 because that is not within the scope. So the first thing whenever you're dealing with these DHCP servers is to realize the scope is the range of IP addresses that the DHCP server is allowed to give out. Now you can, normally what I do when I'm dealing with a DHCP server, if I have computers or networking devices that need a static IP address, generally I'll have those servers. So let's say we have a server here and it needs a static IP address of 192.168. Let's say 1.2, right? So this is the server. Let's say this is a small business server, so it needs a static IP address. So I simply make sure that the IP addresses for these static computers are outside of the scope that I give for the DHCP server. So that's generally what I do. But with these DHCP servers, many times you can create what are called reservations. So you create the scope of, let's say, I don't know, 192.168.1.10 all the way up to 192.168. I don't know, 150, right? .1.150. Now this is the total scope. What you can also do is you can create reservations in that scope. So you could say 192.168.1.11 is an access point. So that is another way that you can make it so that the DHCP server doesn't give out an IP address that is being used statically by a computer. So generally, again, what I say that I do is I just leave any computers or servers that need a static IP address outside of the scope, but with some of these DHCP servers, you can actually plug in a reservation that says this particular IP address is already taken by a server or device on the network. Don't give it out to any other computers. Now, since we talked about scope and we talked about reservations, now the next question that we have to deal with is since these DHCP servers have a finite amount of IP addresses that they can give out, what is one of the ways that we can make sure that it doesn't run out of IP addresses simply because computers come on the network, take an IP address, and then leave the network, and then the DHCP server doesn't realize it? Well, how this can be dealt with is by something called the lease. So whenever a DHCP server gives out a dynamic IP address, it leases that IP address to the client. So it doesn't necessarily give the IP address to the client, it leases the IP address to the client. Now you can set up within the DHCP server how long you want leases to last. Do you want them to last 1 day? Do you want them to last 10 days? Do you want them to last 100 days? This is how long the DHCP server will reserve the IP address for that client computer when it asks for it. So if you, let's say you have a coffee shop where lots of people are coming into the coffee shop with their laptop computers and they're continuously getting DHCP addresses and then they're leaving, they're going home. You may want to have a lease time of 1 day to make sure that all those new people coming in, grabbing IP addresses, basically don't take that whole pool of IP addresses and leave the DHCP server with none they can give out. So in something like an internet cafe, you might have a lease of 1 day. On the other hand, if you're dealing with an enterprise environment, let's say we have lots and lots and lots and lots of desktop computers, all for a call center environment. You want them to use DHCP just because it's easier. You don't want to have to manually configure IP addresses. On the other hand, the same 1,000 computers that are sitting in your call center today will be the same 1,000 computers that are sitting in it 5 years from now. Well, there you may use a lease of something like 100 days just to make sure that there's not a lot of network traffic going on simply for renewing IP addresses. So the lease is how long the client is given the IP address before it is given back into the pool. Now what happens is the client computer will try to automatically renew the lease as long as they are on the network. Generally, this happens somewhere around the 50% mark on the lease. So if you have a lease of 1 day, at the 12-hour mark, the client computer will ask the DHCP server to renew the IP address. So if it's a 1 day, after 12 hours have gone by, the DHCP client will contact the DHCP server and say, hey, can I have or can I keep the IP address you've already given me? If the DHCP server thinks that's okay, basically it will automatically say yes, that's fine. And so at that point, you will now have renewed the lease for another one of the lease periods. So whether it's 1 day or 100 days. Now, if the client computer for some reason cannot connect to the DHCP server when it tries to renew the lease the first time, then after a certain period of time, it will try to renew the lease again. So if it is not able to renew the lease the first time, it will still keep that IP address, and then it will wait another prescribed amount of time to try to recontact the DHCP server and see if it can renew it then. Depending on how the configurations are set up, the client computer may do this twice, 3, 4 times. At a certain point, if it cannot contact the DHCP server, it will release its IP address, and then it will go back to not having an IP address at all. So that is what the lease is. So at this point, so we've talked about the scope. So the scope is the total pool of IP addresses that the DHCP server is able to give out. Like I said, 192.168.100 to 192.168.1.200. Now what this scope is up to you. You could have a scope of 10 IP addresses. You could have a scope of 1,000 IP addresses. It's whatever you plug in to the server to give out for the IP addresses. Then basically, as I say, normally in the real world, I don't bother with reservations. So reservations are if you have servers or computers on the network that need static IP addresses, you can actually plug that into many DHCP servers. So you create the scope, whatever it is, and then within the scope, you say 192.168.1.200 needs to be the small business server. That's what the reservation is. Normally what I do is I create the scope, .1.100 to .1.200, and then I make the server be 192.168.1.2 or 192.168.1.3. So normally I just create all the static IP addresses in a nice little cluster, usually at the beginning of the network, the subnet that we're dealing with, and then I create the scope further down so that there's no conflict there. The big thing though to remember is this whole leasing scheme. So the big problem with DHCP servers is you don't want them to run out of IP addresses. If the DHCP server only has a pool of 100 IP addresses, and it gives out all those 100 IP addresses, and then the 101st client computer tries to connect and get an IP address, well, then there's no IP addresses for that DHCP server to give out. So one of the ways that you try to make sure that you have enough IP addresses is through this leasing scheme. So the DHCP server leases an IP address to a client computer for a certain amount of time. You plug it in, either it's 1 day or 100 days or 5 days, whatever it is. Then while the client computer is connected to the network, at a certain set interval, it will try to contact the DHCP server to renew the IP addresses. So this is the basic thing that's going on with the DHCP server. Now, in order for the client to connect to the DHCP server, this is just a normal communication scheme that you see with almost all networking protocols. So basically, you have your client computer here, and when you connect it to the network, it is going to send a communication out, and it's going to go out all over the LAN. So it's going to send a request over the LAN to ask for an IP address. This is called DHCP Discover. So it's going to send out a DHCP Discover signal to ask, to say, hey, I need an IP address. Can anybody give me an IP address? Well, the DHCP server on the network will hear that DHCP Discover request, and it will send what is called a DHCP offer. So this is an offer of an IP address and all of the information. The client will then send a DHCP request saying that, thank you, I've gotten the DHCP IP address and the information, and I am going to keep it. And then the DHCP server sends back an acknowledgement saying that everything is A-OK. So this is how the communication goes. The client computer sends out a discover, then an offer is given, then the request is given back, and then there is an acknowledgement. Now, if you've seen something here, if you've seen a security hole, you get an extra brownie point. Now with this DHCP communication, you will notice that for the most part, there is generally no security. So how does the client computer know that they should take the IP address given from this particular DHCP server? Well, guess what? They don't really know that. So if you have two DHCP servers on the network, if you don't have some kind of security policy in place, basically the client computer will take the DHCP information given by whatever DHCP server gave it the information first. So this is something that you have to worry about with hacking and security, so on and so forth, is you want to make sure that any DHCP servers on the network are in fact yours, because if you can put a DHCP server on the network that is compromised, let's say it gives back the wrong DNS information, then you can have a lot of problems. Then you can create a lot of havoc on the network. But basically, you have the client, it asks for a DHCP address is given, the request is acknowledged, and that's how the IP addresses work out. So this is a basic overview of how DHCP, Dynamic Host Configuration Protocol, works. It's a pretty simple protocol, at least from the administrative standpoint. There's not a lot to this. Again, this is built into everything, including cheap little, these little routers or ISP modems. There can be a lot of complication to DHCP, but generally when you deal with it, it's going to be pretty simple. So if you're dealing with your router, basically all this is going to ask you for is a primary and secondary DNS servers and what the scope should be. That's really all it's going to ask for. It's pretty simple. On the other hand, if you're dealing with a Windows 2012 server, you can do a whole bunch of different things. You can create reservations, you can create multiple DHCP servers, you can create things called super scopes. It can get really complicated. But basically, what I showed you today is the general concept of DHCP so you understand what's going on. So you've got the scope, which is the pool of the IP addresses. You've got reservations that state certain computers should have certain IP addresses. You have the lease. The lease is the length of time that the IP address is given out. And again, when the communication for a DHCP client to get an IP address goes out, do remember, if you don't have a secure network, somebody could plant their own DHCP server on the network and start giving out client computers all kinds of bad TCP/IP information, and that can be really hard to track down if you don't have a good security policy. So, as you know, I'm Eli the Computer Guy. This was Introduction to DHCP. As always, I enjoyed teaching this class and look forward to seeing you in the next one.